Um, so for one of my classes for homework, we're making a memory allocator in C, and I decided, wouldn't it be really cool if I didn't do that in C and did it in Zig instead? Um, I'm still doing it in C for homework, but um, now I'm also doing it in Zig for funsies on. I would like it to be cross compatible from Mac OS to Linux because you do get extra credit for making it fully compatible with the standard malloc library. Um, the POSIX malloc library. And so I'm gonna just try. I'm gonna. I don't know a lot about Zig, and I don't know, and I do understand how. I do understand how a how the how malloc works basically. Um, and so I'm going to try to get this to work. Um, so what I don't know. Um, what I don't know is if there are. Um, what I don't know is if there is a. I don't know if there's. Is there tagged unions in Zig? Not that I necessarily need tagged unions. Um, access of inactive. Oh, berry union types. Berry unions cannot. Accessing a field is detectable. Okay. Um, tagged unions are used to detect an enum, which tagged unions they use an enum. What is the size? What is the size of the union? Because I don't. The thing is, you don't want to be wasting like a ton of memory. Um, you don't. Why don't we? Oh no, this is the testing allocator. I know there is a. Equals std dot. There's a page allocator. There is a. And I'm curious how that works. I'm curious how the heap. That's it. Page allocator. Yes. So this. Oh, okay. So this is a very inefficient allocator because it does a syscall on everyone. Syscall directly for every allocation in free. Interesting. Has decal. What is has decal? So I actually have I actually do have the Zig source here. And what I'm curious about is I'm going to be looking at this a lot, I think. Or is it Darwin? Yeah, there we go. Darwin. Check if FTK is installed. What I want to see is what I really want to see is I want to see what the I want to see what the page allocator on macOS looks like. Interesting. Here's page allocator, which is what I think we were looking at earlier. Okay, so you make a V table. Make a V table which has these pointers. Oh, what is this? Oh, it has the POSIX APIs. Sir, it has POSIX APIs. Interesting. Maps files. I'm a little sick, so I think my voice is being weird. It is crazy how much of this Andrew Kelly has written. Like, I haven't seen a single line. I haven't seen a single line not written by Andrew Kelly. How many lines are in this file? I guess this is, Matt, Colin, yeah, it's NT allocate if native OS. Is this this has to be, this should be comp time, I feel, but it's not. Or maybe, I don't know, it's hard for me to read Zig. POSIX map mmap is what the fuck am I looking at? Oh, there's Alec. Alec returns map, which is what we were just looking at. Okay. I don't like that. I don't like the way that's laid out. Okay. Is there Zig? I'm curious. Um, I don't. MLDB, what? LDB Zig. Because what I think I'm going to do, okay. So what I'm going to do is I'm going to actually go to the main.zig. We don't need any tests. 18 down. We'll do const page allocator equals std.heap dot page allocator. Can I do that? What are its parameters? It is a type and a size. Why don't we just and it returns a allocator type. May be required to call free once the memories. Okay, we're gonna look at the ways Zig allocators work again. Oh, it's a try. Oh, and that's why it returns the function. That is a hard thing to read. Mem equals pa.alloc or try pa.alloc 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 we'll say just U8 and we'll just say 20 of them. And so what type is, yeah, that makes sense. And the mem dot what is, how do you free allocator dot, oh, that's right, pa dot free mem let's just do that. Zig build. Come on. LDB zig out bin malloc. Whoa, that looks kind of ugly in this color scheme. I'm not going to lie. Help. What does target mean? Create? Oh, list. Can I do list main? There we go. Okay. Exit. Why couldn't I see anything? Um, break main on 2. Can I do that? No, that's not. Ah! That's not 2. That is line 7. I'm kind of stupid. Break main 2. Can I do that? Create. Help. I'm only used to GDB. Oh, break set. Okay. Breakpoint set. How do I use LDB? LDB. So if I am memory read, process launch, breakpoint, break set, file. Okay, that makes sense. Break set, file, main.zig. What was it, line 7? Oh, hell yeah. And then I can do... Oh, and then you can do tech name. Tech... Function name that... Oh, interesting. Okay. And then I can do... Run... Into? Can I do that? Nope. What is... So if I do steppy, huh? I don't know what I'm doing, because what I want to be doing is align left edges. I'm not really interested in breakpoint. Controlling your program. Thread. CI. Thread and step B. Thread C. Yeah, hold on. Layout, bin, malloc. Okay, so it doesn't crash. I want to, or do I just do, okay, because LD step, go into function. Um, I don't know what I'm doing. I want to... Is it... If I do next... Oh, one. If I do next... Okay, that's what happens. That's not what I meant. So if I run it... If I step into... Up. Ah, yes. Wait. No. It's the zig. I'm in the zig runtime, so I wanna. I am here now. Next. Alec advanced with return. Because self-allocator. So I want to. So why don't we step into? Step in, step in, step in. Is it? Do I just want to step? Yes. Oh, I don't want to do the instruction step in. I just want to step in. That makes sense. Step. Step. Yeah. Comp time. Okay, so we already know what A is. Because it's we're doing alignment stuff. Okay, pointer cast. Yep. Align. Step. I think we can just next. Next. Step in. Yes. Okay, so we're stepping in. We are now in the align bytes. Alec with alignment. We're in the oh yes, we're at raw Alec now. Let's step into raw Alec. Step into okay. Now we're in Alec. Now we're in the page allocator. This is true. Assert n is greater than 0. It's greater than 0. Can I do print n? Ooh. Very cool. Next, and step into that. What is interesting to me, okay. Can I just, oops. Okay, so, why don't we, I don't really care. I am curious though. Page allocator. I was already in page allocator. That's quite funny actually. This is Ian Heap. Where each page, so to utilize this, so when I'm looking at this page size, I lost where we are. Page size. Let's go back. I see the options. Query page size. Const. Driver. Oh, that's weird because we're in the heap. That's Z. Okay. We're in the main heap.zig file. Oh my gosh. Oh, if so we're in a switch statement where is all stack VM info. Okay, cool. What does as do? Okay, you can compare between types. VM info.page size. We have int cat. Okay, that makes sense. I don't need to step through that here. We'll yeah, we don't care about that too much. Aligned length. Why don't we... That... Shh. That's big. That's also really big. What? Oh, is this for the page alignment? Oh no, I skipped over it. But if we look at POSIX, POSIX/map files, length proto map. link libc. I think this might be chasing some rabbits that I don't need to be. What I do care about, I know from class, I know that there is a SBRK syscall on Linux, which gives you okay. It changes the location of program break. I'm curious what is malloc libc? I believe malloc is libc. Yeah. Um, Mac OS. Leah Malik. Lettuce. Magazine Malik. How difficult is this going to be to implement on Mac? Thank you, Apple OSS distributions. Um. Oh, this is for. Oh. Enum. Malik check starts. Malik. Memory pressure. Do I? I'm gonna kernel panic my Mac. I think. Is there a malloc.h? No. Malloc.common.h. Malloc is because when I. Okay, that's not Malloc. Malloc type internal.h. Um. Okay. um. Malloc type.c. Is there like a struct anywhere? Malloc no inline. Oh my gosh. SBRK Maslin. Oh. Very cool. I didn't realize that this is what are Mac OS calls? Is there like a list somewhere? Unironically, if I look at it, if I can like navigate this with my FSP, I feel like I'd be very good. Oh, that's okay. So I wouldn't have been able to find stuff because I was looking for. Okay. macOS syscalls. Where are my syscalls? Using syscalls. What are X and U? Yes, kernel stuff. Let us see. Interesting. cool. If I look at SBRK, is that an option? Fun! Fun! I go S15 syscalls. Kernel syscalls. The Apple Wiki. Let's see. On the kernel end. Mock traps. Okay, so I'm realizing I don't really know what POSIX is. It's something I'm like aware of. But what does it define? It's certified. Mac OS is certified, but like, why? What is mock? Mock's this trap. Semaphore, scary stuff. We don't need. Do we need a thread safe malloc? It's fine. That's a lot of syscalls. Holy shit. Pipe. Symlink. Why is there space right there? Make FIFO. Chud. What is mmap? What is nmap? Okay. Sure, I guess. That makes sense. Pull. Semaphore stuff. AIO, I think. Yeah, did I is Mac OS memory allocator? That's not what I mean. Oh, yes, that is what you use. I am fucking stupid. I can I how? How do I how do I I don't get it. I it's a general purpose allocator. I want I how does program execution work? Um Mac OS expand heap. Heap. What are you talking about? Because, no, what I want to do is I want to expand the heap. Expand heap syscall. I just don't. Mac OS has some examples. Global. Fucking hell. Fucking hell. XNU. Lib syscall. I'm Alec? Cool. Cool. Just a single. Okay. Platforms. OS X. Is this called that map? There we go. Okay. Except bind connect. AO suspend close async of. What? What? If I am mig allocate VM allocate mock. Is there not a mock.h? What I don't get. macOS custom allocator. How do I write one? How do I write one? That's what I want to know. That's all I want to know. Right, custom allocator. I'm not ah. That. Okay, if I look at source, am I going to... Alec POSIX? Do I need POSIX functions? Heap.c, heap.c. OS.c, this is I think what I want. What does this do? We ah, virtual memory system architecture. This is what I want. Interesting. So, if I request a new I love how I don't I don't really know what I'm reading. ASLR pointer authentic. What? Wait. What does that mean? I agree. Authenticated return address. Signed pointer. Signed function pointers. Optional data pointer. Wow. If I find heaps, find heaps starting address. Okay. Mac OS. There's mock stuff. System 5. Now we can cover heap allocation. Okay. It is possible. Bite me turned out inefficient. Utilized. Okay, so we do have to do mmap. What does mmap do? What is unlock? Okay. Mmap error. There's errors. Makes sense. What? If ABIs. If Linux. Okay. Pthread. Dev T? I-32? Sure. I guess. Okay, VMap, what is mmap 64? I'm on line 10,000. Okay. Mac OS mmap syscall. So I don't really. So I guess that's confusing me why we're doing it. SBRK and mmap. In malloc. Memory allocator, the granularity. Slow. Presence of multiple units allows multiple threads to allocate memory simultaneously in separate units. Okay, this is true. Including race conditions. Experimentation. If we're already using mmap, so let's just start with mmap. A memory map cannot be extended, but use limits the allocator to the kernels which support it. Okay. Why are we using this in class? Why are we talking about... Okay. Cool. Now... What if we do mmap... mmap... request memory page... mmap... macOS... mmap allocator. Uh-oh. Taking out right. So that's why the numbers were so big earlier, I think. Memory management. Okay. Oh, this looks helpful. If mapping... It's not... Okay. The adder argument can use to... Okay, we're going to... What we're going to do now... We're going to actually write code. I actually... Where's an... Zig... Map. Mobap. Oh, it's in POSIX. std.posix.map. So we do null six dot null. So we do null. So we don't need anything there. So the page allocator allocates a page every... Wow, that's crazy. The length. We are going to give me that std dot page size. Can I actually I don't know how comp time works. Can I do that? What's prot? Protection flags. Prot right. std dot POSIX dot prot zig prot read prot write. Prot read. No. Okay. Let's go. Okay, I'm gonna look at the page allocator again. Yippee! Page allocator. Oh, you can just do that? Oh, that's cool. Dot read true dot write equals true. I don't think I'm doing this right, actually. I am doing this right. Almost doing this right. Bags. What do you do? Bags. Sure. We'll take that. What is FD? What is FD? What is FD? Map private. Well, I'm not mapping. File descriptor -1. File descriptor -1. I do not need it. And what was that, 0? Damn. Okay. Why? It doesn't like that. Does it not like the... What is it? What part of that does it not like? Fuck you. And this returns A. We're gonna do try const out std.io dot how do I print in Zig print? Debug.print. That makes sense. Print. How do print formats work? We get an address of... Can I do that? Of... Ouch. Does that work? Zig. Zig. Run? Can I do that? Zig. Build. Fuck! Huh? But that's what you do. Hint over... Hint. What is hint? Interesting. Next mmap hint. Other hint. That's fine, but this literally says that. What? What do you mean? What do you mean? What type is that? What? What type is that? It's prot. Why did it? Oh. Why is that? Hi. Why is that? Fuck. But you do it? Oh man, what? Slice, POSIX, nmap. Yeah, because... What? Is it because Prot is here? Huh? Prot equals std dot POSIX dot equals const flags prot equals fuck you. Oh, am I just dumb? Because prot has read, right? Yeah, that's right. What? Yes, there is. What are you talking about? I... Zero... One... 0x1 and 0x2 is not and or. Yeah, that's what I thought. Okay. We're not doing this. We're just gonna do... We're just gonna be doing that. Fuck! What is... Well, what type is out? Did you... Catch. Return. No. You do that. Is that what I'm supposed to do? Fuck you! /m map is slice the pointer. Slice. Okay. That makes sense. Out dot pointer. That makes sense. Fucking hell. What do you mean? Zig print pointer. Zig print pointer. How do I print it? Print. Fuck. Address pointer. Zig. Oh, that makes sense. Make that star. Do I have to do the... It gave me a memory address. What is an align? What is the align though? I don't... Where do I just get it out, actually? Oh, I'm fucking stupid. Out again. I think... So... So those are different addresses, and they look like they're 16 kilobytes apart, which is very cool. So I am let me also do a while. Can I do that? While true. PS aux and grep for alloc. The map. What did they do? View memory of process macOS. What is... Oh, what was it? I saw it earlier. The VM map. That's right. VM map. PID is 73594. Oh. That's a lot. So DB for, so it's, look for D B. Yeah, that makes that makes sense. A lot of copy on writes. Yes, it is allocated. It is at 32 kilobytes. Okay, So that's really good. Oh my gosh, I'm very happy with that. Oh my goodness. Um, wow. Oh, I love that. Um, cool. I think that's probably enough for me for today. I feel like I've been doing this for a while. But, yeah. Yeah, this is really cool. Yeah. Oh, oh, I'm so happy. Um, hopefully I can do some data type stuff next time. That would be really cool. Yeah, okay, cool. Yes, well, yeah. Thank you.